Okay, so this is just one of the harder Suvat questions that you can get, but again, just diagrams are key for me, especially just so I can visually see it, and using a highlighter just to go through the bits that are important. So again, we know it's going on a straight horizontal runway, so it means it's going to be straight, and it's constant acceleration, so that tells me that it's going to be the Suvat equations. Okay, so it's passing point A at a speed of 16. Okay. So point A, I'm not going to try and draw a plane. Normally I would, but I'm not going to. Okay, so the speed at point A is 16 meters per second. It then passes point B at this speed here. So B at the speed of 34 meters per second to the -1. And we're told that the distance between the two is 150 meters. Okay, so Suvat, we're trying to find the acceleration, so we're looking for our A, so I'm just going to put a question mark there. We know the distance is 150 meters. At A, the speed was 16, and at B, the speed was 34. Okay, so just bringing the equations back. So the one that has all of those is going to be equation number 4, because you've got the V, the U, we're looking for the A, and we've got the S. Okay, so this one we're going to need to do a bit of rearranging. So V is 34 squared equals U, which is 16 squared, plus 2 times A, because that's what we're looking for, times 150. Okay. So that gives us 1156. 256, I think it is, but better check, yeah. 256 plus, that's 300, so that'd be 300A. Okay, and then we're just going to subtract 256 from both sides. $900. Okay, and then divide by 300. So we get that the acceleration is 3 meters per second to the -2. Okay, so that's the answer to part A. So part B, very similar. We need to find the time taken from the aircraft between A and B. So it'd be the same values. Again, you can use the acceleration now if you want to, but you don't need to. So before we had these, we're now looking for the time. So back to the formulas, the one that has all of those is going to be number 3. Okay, so again we are going to have to do some rearranging after, but that's okay. So 150 equals a half times, so it'll be 16 plus 34 times by t. So that'll still be 150. This part here is 50, so half of 50 is 25, and then it'll still be t. And then divide both sides by 25, so it'll be 6 seconds. Okay, just beef it up a tiny bit. We should still be able to see C. I'm going to do it over here. Okay, so for C, we need to find the speed of the aircraft when it passes the midpoint. Okay, so what it's saying is you've got A and B. Okay, this is the midpoint, and we need to find the speed at that point. Okay, so we know the whole distance from A to B is 150, so from A to the midpoint, that's going to be half of that, so it's going to be 75. We know the speed at A was 16, and we also know the acceleration because we worked out the acceleration from part A. Okay, so using Suvat, we know that the distance is 75, we know the initial speed at A was 16, we know the acceleration is 3, and we need to find the speed at the midpoints. That's our V that we're looking for. Okay, so the formula that has all of those is going to be the same one we use for here. So V squared equals U squared plus 2AS. Okay, so V squared is what we're looking for, U is 16, plus 2 times 3 times 75. Okay, 2 times 3 times 75, 706. Okay, and then we need to square root it. Okay, and we're just going to round it to one decimal place. So that's going to be 26.6 meters per second to the -1.